Okay. Can you see everyone?
Yes,
Can you
sir.
see the slides?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Is it okay? Yeah. Okay. So you see, yesterday we have stopped where we are discussing about a problem, right? And if you see, this is the problem we are discussing, that a 1 meter by 2 meter footing to be constructed at a depth of this, and yesterday we have tried to understand this problem. So net ultimate bearing capacity if the water table is at a depth of 2 meter below the ground level, how to find it out. I hope that you have understood it. Okay, is there any doubt on this So what we have said, you will have to use Terzaghi's bearing capacity equation, and when you will be using Terzaghi's bearing capacity equation, two things you should remember for solving this problem. One is, while applying the Terzaghi's bearing capacity equation, you need to remember that the bearing capacity equation is for general shear failure and strip footing. So as in this problem, the footing is given as a rectangular footing. So what you will have to do, you will have to apply the shape factors in the bearing capacity equation along with the water table correction factor. And for the case number 1 or the problem number 2a, we have seen that when the water table is below the 2 meter from the ground level, we have seen that there is the water table is existing beyond the limit of influence. So there is no effect of water table on bearing capacity, and therefore we have said that the water table correction factors, which are basically RW1 and RW2, those two factors will necessarily become 1 in that case. So only with shape factors application into the Terzaghi's bearing capacity equation, you should be able to find out the ultimate bearing capacity. And once you find out the ultimate bearing capacity, you should be able to find out the net ultimate bearing capacity. How do you find out net ultimate bearing capacity? From the ultimate bearing capacity, you just subtract the value of the surcharge or the overburden pressure, and the overburden pressure is given by nothing but gamma into D. Okay. Now let us go to the next part of the problem. See the similar problem, but with a different data, different kind of problem definition. You see the same footing remains same, 1 meter by 2 meter, 0.75 depth, soil is C5, cohesion, angle of internal friction remains same, unit weight remains same. However, you see in the question number B, what it is asked, it is said that you find the ultimate bearing capacity if the water table is at a depth 0.25 meter below the base of the footing, So what do you think, what will be changed in this equation in that case? What will be changed in this Terzaghi's bearing capacity equation in that case? Can anyone tell? So see, I am writing this equation again here. See what we have said, that Q ultimate ULT if I write, or QU if I write, Q ultimate, which is nothing but your bearing capacity, ultimate bearing capacity. This Q ultimate is given, as you have seen, it is given by nothing but C into NC, then what is there? CNC, and then SC. So you see CNC SC, this factor is there. Then you see this next factor which is Q. What is Q? Q is nothing but gamma into D. I am writing GAMA, gamma into D into NQ. So NQ, so NQ, and then you have that shape factor correction, which is nothing but your correction of shape factor is nothing but your SQ. So S of Q and SQ. After that, will there be any part in this equation? Can anyone tell? Should I multiply anything else with this equation in this term? What should be multiplied to take the effect of the water table? Can anyone tell? See, what will be multiplied?
RW1.
RW1. Yes, absolutely correct. So you need to multiply with this RW1. So to take the effect of water table, you multiply it with RW1, and then you see the next part is nothing but 0.5. Then you have gamma, and then you have B, and then multiplied by B, and then you have N gamma, N of gamma. So N gamma, and then you have the shape factor correction, that is S of gamma and S gamma. And then should I need to multiply anything else to this one? Anything else should I need to multiply? Pardon?
RW2.
RW2, yes, RW2. So RW1 and RW2 are the water table correction factor. You now understand this. So this is actually the modified form of Terzaghi's equation, right? So in this modified form, you see, you know what is C, what is NC, what is SC by now, because SC is nothing but your shape factor, SQ is equal to 1, S gamma is equal to this. You know all these things, right? However, you see this RW1 factor you need to change, right? This RW1 factor and RW2 factor you need to change. In the previous problem, what we have seen in the case number 1 or problem number A, what we have seen? We have seen when the water table is at a depth 2 meter below the ground level, there is absolutely no impact of the water table correction. However, let us see whether there will be any impact of water table when the water table is remaining at a depth 0.25 meter below the base of the footing. So what does it mean? When the water table is remaining at a depth 0.25 meter below the base of the footing, that means what does it say? It says that your water table, the location of the water table, in this case you see the location of the water table is basically here, right? Somewhere here. That means it is just remaining at a 2.5 meter depth. That means your water table, just the same picture if you see, in that you see this is the location of the water table. So this problem says from the base of the footing. So base of the footing, you should understand this properly. In the previous case we have seen the location of the water table from the ground level. This is very important. Whereas in this case, you see what is being asked, water table is at a depth of 0.25 meter below the base of the footing. So below the base of the footing. So where is the base? Base is located over here. Base is located over here. So this is from this base of the footing. This is actually your 2.5 meter. Okay, this is actually your 2.5 meter. So you tell me now, what will be the value of dw dash in that case? Tell me.
2.5.
What will be the value of dw dash? So if I take this formula out and if I put it here, let's say if I am putting somewhere here, then you tell me what will be the value of this dw dash in this equation? Bolo?
0.25.
Yes, 0.25. So you should be very clear about it. Okay. So see, dw dash, whenever it is given, it is basically taken from the base of the footing. So dw dash value So to calculate the value of RW2, what you'll have to do, you'll have to do RW2 when you'll be calculating. So if you are calculating RW2, then RW2 is basically given as, you see, is equal to, what is the formula? 0.5 into 1 plus dw dash, just I am writing like this, okay, dw dash divided by what? Divided by b, right? So you tell me now what will be the value of RW2? So it will be 0.5 multiplied by 1 plus, what is dw dash? One of you have told it. It is 0.25 meter.
0.25.
And what is the breadth of the footing? What is the breadth of the footing you have
1
said?
meter.
What is the definition of the breadth of the
1
footing?
meter.
Breadth of the footing is equal to 1 meter, right? So you put the value of b over here. Where it has gone? Here. So put it the value of b over here. So what it will become? See, this problem is now, it is 0.5 multiplied by 1 plus 0.25, right? So 1.25 multiplied by 1.25 multiplied by 0.5, how much it will come? So let's say
6.25, 0.625.
0.625, okay, 0.625. So you got it. So your RW2 value, this one will become 0.625. Now you tell me what will be the value of RW1? What will be the value of RW1 in this case? Anyone? Where is the water table located? You tell me. Water table is located over here, right? So will there be any impact on this portion of the soil up to the depth of the footing? Will there be impact of any water table? What we have said? See, you should remember these things very clearly, okay? So you see what we have said yesterday, what we have discussed yesterday. If you remember this point, where is that? Where it has gone? See, beyond depth B it is 1. Now when the water table is at the base of the footing, RW1 should be equal to 1 and RW2 is equal to 0.5. Now you see where is this RW1 is now located, the water table is located. It is located below the base of the footing. So there will not be any effect of water table up to the depth of the footing. That means on the surcharge, and you can very easily say, see this gamma, that means the bulk unit weight of soil will remain same because the water table is now located over here. So when the water table is located over here, absolutely there will be no impact of water table up to the depth of the footing, and thus this problem, it becomes simpler, and you will see that the value of RW1, thus we can easily say that RW1 value will be equal to 1. Okay. Now you see, now the problem is very simple. Now just simple calculation. So you know C, you know what is the value of NC, you know SC value, you know gamma, every value you know, and you know what is RW1 and what is RW2. So you know the shape factors value SC, SQ, S gamma. You know what are the values of bearing capacity factor NC, NQ, N gamma. You know what are the values of unit weight of soil and the soil shear strength parameters, that is C and phi, and also you know what are the water table correction factor RW1 and RW2. Now you observe here that typically if you see in the previous problem, the question number A, when you have solved the question number A, what is the difference between question number A? What is the difference between question number A and question number B? You tell me. What is the difference? A, difference, B. What is the difference? You tell me.
Sir, in A there was no effect of water table.
Yes.
And
correct, bolo bolo.
In V there is effect of the water table.
There is effect of the water table, and now you tell me what this effect will change in the ultimate bearing capacity. Can you tell me what this effect is going to change the bearing capacity? What will be changed for this bearing capacity with this effect of this water table? See,
It will get reduced.
see this ultimate bearing capacity. I'll just remove this. Okay, this equation. This is disturbing. Difference, RENC. So you see A difference B. If you see, so while calculating the problem, while calculating the problem definition for question number A, you see you got RW1 is equal to 1, RW2 is equal to 1. Other than that, you see the equation will remain same. So you see the value of QU will be little more than whatever you will be getting in case of B, because you see this term will remain same in question number A and B. This term is also remaining same in question number A and B, because you understand in question number A also we got RW1 is equal to 1, and in question number B also we got RW1 is equal to 1. So up to this term, you see the values or the quantity calculation from these two factors will be remaining same. However, you see what will happen to the third factor, this beta, this 0.5 gamma B n gamma S gamma, up to this it will remain same. But you see for question number 1 or question number A, you notice this RW2 factor was 1. However, today we have seen that when the water table is rising little up to the base of the footing or little below the base of the footing, at that time you are having some RW2 factor which is lesser than 1. And what is the impact of this factor? This factor is ideally going to reduce the value of this gamma, and that's what we have explained and discussed in yesterday's class. Okay, so this gamma value will be reduced by this RW2 factor, and thus if you see in the question number B, this value will be lesser than this value of A. So ultimately what you are getting, you see, ultimately the Q ultimate whatever you will be getting, so whatever you will be getting for let's say here, if you see that if you calculate Q ultimate from A, that is going to be more than Q ultimate B. So you understand now what is the effect of water table in bearing capacity. So once your ultimate bearing capacity is more, you see obviously your net ultimate bearing capacity will change, and your net safe bearing capacity will change, safe bearing capacity will change, everything is going to change. So the effect of water table on bearing capacity is actually, you have understood now through this problem, that it will reduce the ultimate bearing capacity. Is it clear? Okay. Let us go to the next part. Third part.
Sir,
Yes. Yes.
RW1 part again.
Huh?
RW1.
Yes.
How it become 1 sec?
I cannot hear you. Just little bit louder. You tell.
Sir, RW1 part.
RW1.
How
Why
it
is it
become
1?
1?
Why is it 1? Right?
Yes, sir.
That is what you are asking, or something else?
Sir, why it is 1?
Why is it 1? Why is it 1? That's what I was explaining again and again. See, RW1 will become 1, because you see RW1 factor, RW1, this is valid for what? This is valid up to this depth DF, and water table hasn't reached this depth DF. Water table is much below this depth DF. You see, water table is remaining here, which hasn't reached this depth DF, and it hasn't. If this water table reaches somewhere here, then only water table will make effect, or if it comes here, then only water table will make effect. Up to this, when the water table will be just touching the base of the footing, there will not be any impact of water table on the RW1 factor, because when the water table will be crossing the base of the footing, that means when it will be reaching here, then only the impact will be started coming, and that's why RW1 factor will be getting affected. Because you see, where is in this equation you see this D term is coming in this equation, in this part, and this D term and the gamma in this D part will be getting affected by the presence of water table only when the water table will be reaching above the base of the footing. When the water table is here, when the water table is here, when the water table is here, here, everywhere, it will be impacting the bearing capacity, and the value of RW1 will change. I think in the third case, whatever we will be discussing, case number C should be taken that consideration. Let us see. So you see, in the third case, case number C, or the problem number C, if you see what is being asked, it is asked that you find out net shape, gross shape, bearing capacity. Forget about this net shape, gross shape, all this term. Okay. So whenever you want to calculate any bearing capacity, be it net ultimate, be it net shape, be it gross shape, whatever you want to calculate, first you will have to calculate ultimate bearing capacity. Because if you remember the definitions I have discussed earlier, in that you have noticed that from the ultimate bearing capacity only you will be able to get the other values. Okay. So whenever you are asked to solve such kind of problem, you first always calculate the ultimate bearing capacity, because only the formula for bearing capacity you are having directly available in your hand is the formula for ultimate bearing capacity. Now you take this example. So it will be the question, whatever you have asked, it I think will be more clear with the understanding of this case. Let's say now the nets. Now if the water table, you see, if the water table is at a depth of 0.35 meter from the ground level. So can anyone mention where it will be? So 0.35 meter from the ground level. So what does it mean? What does it mean? So 0.35
above the base of the foot.
Yes, 0.35 meter from the ground level. That means, you see, I'll try to show it. So basically it says this is your ground level, this is your ground level, right? This is actually your ground level. So from this ground level, the water table is remaining at a depth 0.35 meter, na? So 0.35 meter. So let's say the water table is now reached over here. So water table is remaining here. And what is this depth? What is this depth? This depth is defined in the question, that is as 0.35 meter. Have you understood it? Have you got it?
Yes, sir.
Yes.
Yes.
So if you see,
Yes, sir.
if the water table has reached this depth, then you see, then the impact of water table on RW1 will come, because you see now the water table has reached at such a depth which will be impacting the soil above the base of the footing. That means up to the base of the footing, the unit weight of soil will be getting impacted because of the presence of this water table. And thus, if you want to take into account this value, then first I will discuss about RW1, then we will go to RW2. So what is the value of RW1? So RW1 is nothing but, you see, this is RW1. 0.5 we have said dW by D. This is what is RW1. This is what is RW1. If you go back to slide and you see, we have written dW by dF, and here we are saying dF means depth of the foundation, and depth of the foundation we are taking as D. So RW1 is nothing but 0.5 1 plus dW by D. Now you tell me, what will be the value of dW in this case? What will be the value of dW in this case? Can anyone tell? This is your dW. So what is dw value? So
0.35.
dw is nothing but
0.35.
yes 0.35. So you see it is going to be 0.5 multiplied by 1 plus 0.35 35 divided by what is the depth of the footing? Is it 1 meter or 0.75 meter? Should I put it 1 here?
0.75.
Yes, you should not put the value of b. See the formulation you must remember. So here you will have to take dw upon df. On this case you will have to take dw dash upon b. So in this case you put it 0.75. Is it clear? So let's calculate what will be the value. CL CA
0.733.
CALC 0.73. So it is
33.
going to be 0.35 by 0.75 equal to this plus 1 equal to this multiplied by 0.5, that is going to be equal to 0.73. Absolutely correct. So it is going to be 0.73. Okay, so have you got it? Have you got this point? So see, this RW1 value is going to be 0.73. Now what will be the value of RW2 in this case? What will be the value of RW2 in this case? Will it remain 0.625 or will it be something else? Should I
Sir,
put it here?
RW2 will be 1.
Well, yes. Should I put? See, that is what is the point. Whosoever has told it, it is absolutely correct. Because you see, when the water table has reached above the base of the footing, you need not to think about RW2 factor here. Because RW2 factor will be equal to 1. Because you see, your water table has crossed the base of the footing. That means, this influence zone below the base of the footing, that is up to the depth B, all the soil is actually getting submerged into the soil, submerged into water. So in that case, when the totally it is submerged, so you see this factor is not to be taken considered, and this value RW2 is going to be equal to 0.5. Have you got it? If you have any doubt, you tell me. Why it is 0.5? You understood? Why it is 0.5? See, when this water table has reached this depth, then what will be the value of dw dash? Dw dash will become equal to 0, because the water table has already crossed the base of the footing. So all the soil below the base of the footing is in a submerged condition. So whenever the soil is under the submerged condition, all the soil is under the submerged condition, in that case what will happen? All the soil, when it is under the submerged condition, what you will have to take care about is that you reduce the water table correction factor to a value of 0.5. So you see, if you now put back this value of RW1 and RW2 into this equation, you are going to get the value of Q ultimate. So if I say, then again there is a difference if I put. So you tell me now, what will be the difference between A, B and C? So Q ultimate A will be more than Q ultimate B, and Q ultimate B, you see, now what is happening? Previously this RW2 was 0.625 and this RW1 was 1. So that was Q ultimate B. Now if you are putting this value of 0.5 over here, it will reduce more. On top of that, RW1 instead of 1 you are putting 0.73. So this value will be also reducing more, and that way this Q ultimate B will be more than Q ultimate C. So you see, have you understood now what is the effect of water table on bearing capacity? So once you have
Yes, sir.
calculated the ultimate bearing capacity, then from the ultimate bearing capacity you just directly apply the formula to get the values of different bearing capacity numbers that is given over here, if you remember. So net ultimate bearing capacity. So once you have found out what is the ultimate bearing capacity, you can find out the net ultimate bearing capacity by subtracting this gamma df, and then you calculate net safe bearing capacity. So net safe bearing capacity you can calculate by dividing net ultimate bearing capacity by the factor of safety. So you can assume, in absence whether it is not, if it is not given in the problem, what is the factor of safety to be applied, you can assume a value more than 1.5, or you can, if it is given in the problem, you apply that value. In this case, you see, for finding out, it is being asked that you find out net safe bearing capacity. So for net safe bearing capacity, it is said in the problem itself that factor of safety value is 2. So factor of safety is 2 means you apply the value of f as 2, and once you find out the net ultimate bearing capacity QNU, you divide it by factor of safety 2, you will be able to get the net safe bearing capacity. And once you get the net safe bearing capacity, to the net safe bearing capacity, if you add up the value of what is called surcharge, that is going to give you the value of gross safe bearing capacity, and that's what is asked in the question also. See, you will have to find out net safe bearing capacity and gross safe bearing capacity. So is it clear? See, this problem is a very good problem. So you have understood through this problem how to find out the bearing capacity, how to find out the bearing capacity, as well as how to find out the effect of bearing capacity. You, because of the water table, different presence of water table at different positions. Also you can find out using this problem, through the help of this problem, you can have the understanding what is the effect of safe factor on bearing capacity. So if you have any question, please ask, otherwise we will proceed further. Is it clear? So are you do you think that this way, if I explain, it will be good for you? In this Word document, if I write some way and solve this, show you the solution of the problem, it will be good for you? Anyone?
Yes, sir.
Yes, sir.
It will be
Yes,
good,
sir.
or it will be bad? Or you want
It
some
will be
PDF
good.
documents where I will just send you the problems and you will see it?
No, sir,
It is
ठीक
better,
है,
sir.
It is better, but
Yes,
it is
sir.
very time consuming
Yes, sir.
and too much efforts. So anyway, we'll try to explain in this way. Okay, so conceptual problems, okay, I'll try to give you in this way, okay, but you will have to work out your own the problems, okay. So today, after this class, or maybe tomorrow, I'll share you some problems, okay, from one of the books, very good book, okay. Some worked out examples I'll send you. So you please try to solve those problems, okay, because if you do not practice these problems, you will not be able to get the feeling about how to solve the problems of bearing capacity, okay. So let's say I'll explain another one problem. Let us see. I have downloaded it, I have scanned it yesterday. See, let me see, show it. See, can you see this? Can you see this?
Yes, sir.
Is it clear
Yes,
to
sir.
you? Is it clear?
Yes, sir.
Okay.
Yes,
okay.
sir.
See example 16.1. Okay. I think which book I have taken. This one is. I'll tell you the name of the book later. We don't recollecting the name. Okay. So all of you have joined, right? So I can take your attendance at this point. Let's take the attendance. So Google Meet attendance collector. Let's see. 37 members. Now it is 34, but it is 37. Let's refresh and download it. unit attendance collector, 47 member. What is happening? See, double you have entered, right? That's what is problem. Multiple time you have entered, means one with your own name and then one with your roll number and name, I think. That is why it is increasing. That is why it is increasing, I think. Anyway, I'll take it. Let's see. Okay. Where is that PDF? Yes, here. So see, before we get into more theory, let's discuss today problems only. See, now you see this problem. This is much simpler problem. Whatever we have discussed till now, it is little bit simpler than that. See, what is this problem saying? A 2 meter wide steep footing is founded at a depth of 1.5 meter below the ground level in a homogeneous bed of sand having the following properties. Phi is equal to 36 degree and gamma is equal to 16.5 kilonewton per meter cube. And you see in this question what is asked? You are asked to find out the ultimate net safe bearing capacity. So everything it is being asked. This is the simplest form of the problem where everything is asked. Okay, but you should remember that always you will not be asked in this way. You may be asked only this part, that what is the safe bearing capacity. So you see, once you are asked to find out the safe bearing capacity, you will have to find out everything. That is, first you will have to find out ultimate bearing capacity, then you will have to find out net ultimate. From the net ultimate you will have to calculate net safe, and from the net safe you will have to calculate safe. Okay, and see here also the factor of safety is given. Okay, so you see in this problem, if you notice, the phi is given as 36 degree. So necessarily this problem will become a problem of what? Problem of bolo? Local shear failure or general shear failure? Huh? Local shear failure or general shear failure?
General shear failure.
General shear failure, yes. So once this problem, once the problem is a general shear failure problem, then problem becomes very simple. So let's say let's try to solve this problem. Let's not see this. Let's try to solve. Okay. So you will tell me now. Okay. Next page. Let us go and let us try to solve this. So let us try to solve here. So you tell me now from this problem. So in this problem you tell me what will be the bearing capacity equation. I am taking this bearing capacity equation from here. So let me copy it and paste it over here. So this is your bearing capacity equation. So for this problem, do I need to have this shape of the bearing capacity equation, or should I change it something? What does this problem say? The problem says, you see, it is a 2 meter wide. 2 meter wide. What does it mean? Wide means 2 meter wide means B is equal to width of the footing is 2 meter, right? So B is equal to 2 meter. And you minutely notice what is the next point the problem is saying? It is a strip footing.
Strip footing.
So if it is a
Formula
strip
will be
footing, do
applied
I
on it.
need to apply safe factors?
No, sir.
No, because
No,
safe
sir.
factors, yes, if you apply safe factors, because the formula for Terzaghis bearing capacity equation is given for general shear failure and strip footing, right? So that's why in this case what will happen? Your this SC, SQ and S gamma, all these three factors will become equal to 1, and that's what you see in the presentation also. If you notice, when you have discussed about this safe factors, you see what we have said. When the footing type is strip, the value of SC, SQ, S gamma are 1. So if the values of SC, SQ, S gamma 1, you see this equation becomes little simpler, and actually it is going back to Terzaghis basic equation. Sorry. So you see, it is basically going back to Terzaghis basic equation. Until now it is not, it hasn't become the Terzaghis basic equation. Now see, till we have RW1 and RW2 factor, do we need to keep this RW1 and RW2 factor in this problem? Is it required? Tell me. Tell me. Hello. Hello. Are you there?
Yes, sir.
Bolo.
Yes, sir.
RW1 and RW2 factors, do I need to keep here or not?
Mm, No, sir.
No, because see, in the problem anywhere it is mentioned that water table is present, where the water table is present, this water table will affect this, that. Has it been said in this problem? No. So you see, in this case you don't require to have this RW1 factor, and you don't require this RW2 factor. So necessarily you see this equation becomes simpler, and you see this equation is nothing but basic Terzaghi's bearing capacity equation, which is applicable for a strip footing and for general shear failure. Okay. Now you see this, in this problem, to find out this, you tell me now from your knowledge of soil mechanics, see, given what is the type of the soil? Is it a C5 soil or it is just a phi soil? What do you think from the definition of this problem? Is it a C5 soil or it is only a phi soil? Subodip, tell me.
Only 5, sir.
Only a phi soil. Yes, only a phi
Yes,
soil.
sir. Only 5, sir.
Yes, because see, there is no C, so the soil is not having cohesion. So necessarily it is a purely sandy kind of soil, sand kind of soil, right? Only it is having angle of internal friction and cohesion is not there. So that means, what does it mean? That means, you see, it means that your phi value is there, however your C value is equal to 0. Okay, but you notice another one thing, you have a phi value. Let's say I am taking this phi from here. So let's say you have a phi value and the phi is equal to 36 degree. So when the phi is equal to 36 degree, you see, for phi is equal to 36 degree, you are going to have the values of NC, NQ and N gamma. Please try to understand. That is why you see NC, NQ, N gamma values are given, but you should not get confused over here that अरे NC value कहाँ से आ गया? C is not there, so how does NC will come? See, there is no relation between C and NC. Bearing capacity factors are not dependent on cohesion of soil. That's what you should understand and you should remember. Bearing capacity factor values are only dependent on the angle of internal friction, and that's what is being defined by Terzaghi. And if you see the Terzaghi's table of bearing capacity factors, Terzaghi's table of bearing capacity factors, somewhere I have shown it, right? Where is it? Where is it? This one. So you see, if you see this Terzaghi's factor, you see it is only dependent on phi. So you don't think that if C is equal to 0, then NC value will become equal to 0. See, only in case of phi is equal to 0, N gamma will become equal to 0. That's what I have explained you earlier also. But your NC value will not be equal to 0. So when your C value is becoming equal to 0, then you multiply this NC with C, it will become equal to 0. So necessarily you see in this equation what will happen, you don't require to have this CNC term also, because C is equal to 0. So necessarily for a typical phi soil, you see the equation becomes gamma d NQ plus 0.5 gamma b n gamma. Have you understood it? Now you see all the other values are given very well defined in this problem. The gamma is given. So gamma is 16.5, it is given. So NC, NQ, N gammas are given. So you know what are the values of NC, NQ, N gamma. So you require NC is not required as C is equal to 0. You know what is the value of NQ. You know what is the value of N gamma. So you know what is the value of NQ. You know what is the value of N gamma. So NQ value is known, N gamma value is known. Okay. Now once you know the value of NQ and once you know the value of N gamma, do you need to know any other thing in this equation to solve the problem? What will be the value of B? B is equal to 2 meter. And what is the depth of the footing? Is it given in the problem or not? It is given. See, the depth of the footing is 1.5 meter below the soil. So D is equal to 1.5 meter, and your 5 meter, and your gamma is given as 16.5, right? 16.5 kilonewton per meter cube, and other values of NC, NQ and N gamma are also given. You see, these values are also given. So if you take these values here, you could put it here. So let's put it over here. So it's C. These are the values of NC, NQ, N gamma. So see, you don't require NC value here because your C value is equal to 0. So C and C factor will be automatically becoming 0. So put the values of NQ, N gamma, B gamma, and you are going to get the value of Q ultimate. So once you have found out the value of Q ultimate, other things are very simple. So in the problem, if you notice, it is being asked to find out the ultimate bearing capacity. So you understand what is ultimate bearing capacity and how to find out. So you see how the problem solution goes. See, this is the way, whatever we have discussed, this is the way the problem is going. So 16.5 into 1.5 into 42. So that's what we are having here. So what will be the value of this? It will be nothing but gamma is equal to, you see, 16.5 multiplied by, what is D? D is equal to 1.5 multiplied by NQ. NQ is equal to 42. So multiplied by 42 plus 0.5 into gamma is 16.5 multiplied by B. B is given as 2 meter into N gamma is equal to 47. So see, are you getting this? 16.5, 1.5, 42, 0.5, 16.5, 247. Okay. So you see, you can find out, if you calculate this value, you are going to get this value in kilonewton per meter square. Okay. So kilonewton per meter square, because you see the unit of 16.5 is what? You must understand this unit very well. This 16.5, the unit of this is kilonewton per meter cube. The unit of this is kilonewton per meter cube, and this is having unit of meter. So if you multiply kilonewton per meter cube with meter, you are going to have kilonewton per meter square, and that is nothing but kilopascal. Okay. So kilonewton per meter square means kilopascal. So you can report it using kilonewton per meter square also. There is no problem. And you see these factors, this NC, NQ, N gamma, if you remember, we have mentioned these are dimensionless factors. These factors do not have any unit, and when these factors do not have any unit, this is not going to impact your dimension of this QU quantity. So ultimately the value of this you will be getting in kilonewton per meter squared. Without this unit, your problem will be totally wrong. Please understand, you will have to mention this unit properly. After solution and during the solution of this problem, you must mention what is the unit, that is kilonewton per meter square. So once you find out the ultimate bearing capacity of the soil, after that, you see, step by step you can just apply the formula. Whatever we have discussed during our definition. So see, exactly the same definitions we have said. So net ultimate bearing capacity. What is net ultimate bearing capacity? You just subtract from the ultimate bearing capacity the value of the what is called overburden pressure or the surcharge, and that is nothing but, it is basically, if you want to find out Q net ultimate if you find out Q net ultimate is nothing but your Q ultimate minus, you'll have to subtract what? Gamma into D. So you will have to subtract gamma into D. So what is your Q ultimate? Q ultimate value you have calculated from this equation. So put the value of Q ultimate here and then gamma into D, and gamma into D is nothing but 16.5. So 16.5 multiplied by D in this case is how much? 1.5. You see, whatever Q ultimate value you have calculated in this problem solution also, if you notice, 18.15 is calculated as Q ultimate. So from the 18.15 you see gamma into D, so gamma is 16.5 into 1.5 is subtracted, and you are going to get the net ultimate value. Okay, now from the net ultimate bearing capacity, what you get? You want to get net safe bearing capacity. So net safe bearing capacity is what? Net ultimate bearing capacity divided by factor of safety. So you get net ultimate bearing capacity, and what will be your net safe? What will be your net safe? So your Q net safe is going to be equal to Q net ultimate divided by factor of safety, and in this case you see in the problem it is defined the factor of safety. If you see in the problem it is given the factor of safety value as 3. So what value you will have to put here? So in case of factor of safety you put value of 3. So from this you should be able to get the Q net safe, and once you calculate the Q net safe you will be able to calculate Q gross safe. And you see, this is what is being asked in this problem. So ultimate, net safe, ultimate bearing capacity, net safe bearing capacity, and safe bearing capacity. Okay, net ultimate and safe bearing. So gross safe or safe bearing. So you see, in this case we have said gross safe bearing capacity. This gross safe bearing capacity, in sometimes this gross term is not being mentioned. Instead of that, only it is said safe bearing capacity. Don't get confused this safe bearing capacity with safe bearing pressure. Safe bearing pressure comes from the settlement analysis, whereas safe bearing capacity, which is nothing but your gross safe bearing capacity, this is actually what you will have to do. You will have to add up your surcharge value to this net safe bearing capacity. So you add up this whatever net safe bearing capacity, so whatever Q net safe you have calculated, you add to this your gamma into DF. So your gamma is in this case 16.5 multiplied by DF is 1.5. and you see this problem, in this problem solution also, if you notice, this is being done. So what is being done? Whatever net safe they have calculated, this 596.75 value, to this they are adding up 16.5 into 1.5, and every value of this, every value will be having unit of, don't get confused, every value is going to have, every value is going to have this unit, kilonewton per meter square. This will also have unit kilonewton per meter square. This will also have unit kilonewton per meter square. Is it okay? So you see, this is what is actually happening. This is what is actually happening. So you take into consideration this problem as a very simple form of the problem. So this is the most simplest form of bearing capacity problem. If you understand this problem, then only you will be able to get into more details about the other problems. Okay, we will take up more problems in the next classes. As well, we will be discussing about more theory and the effect of other things on bearing capacity, and then we will start a discussion on Indian Standard Code. Okay, so we haven't yet solved, we need to solve some problem of local shear failure. You see, till now we have taken up the problem for general shear failure only. So we need to take up some problems of pure local shear failure. That means when the shear failure is happening and the angle of internal friction is less than 29 degree or less than 28 degree, such kind of problems we will have to solve. So pure local shear failure problem, as well as we will have to take into consideration some problems where mixed mode of failures are happening. That means the shearing strength parameter, that is the phi of the soil, is remaining somewhere between 29 and 36. That means let us say the soil is having angle of internal friction as 30 degree, 31 degree, 32 degree. So 31 degree, 32 degree, either you can assume it as a general shear failure criteria or you can assume it as a local shear failure criteria. But actually in such kind of soil, ideally there will be a mixed mode of failure. That means there will be general shear failure mixed with local shear failure, and we will take up one problem to discuss this. The problem definitions, or the problem solutions I will be sharing with you. It has got one problem relating to that. I will suggest you go through this problem very carefully before we discuss it on the next day, or maybe in one of the classes we will be discussing it. See, we have you see, this is what is the problem number 16.3. if you see, the phi parameter is given as 30 degree. Okay, so 30 degree means it is neither a shear failure which is general shear failure, or it is not a proper local shear failure. So you need to consider a mixed mode of failure in this case. And how to calculate the bearing capacity in case of a mixed mode of failure, this problem will be, this example will be explaining you in detail about it. It's a very simple thing, but I'll explain this problem later. Okay, I'll explain this problem later, but I'll request you, after I share this document with you, you please go through this carefully. Okay, and then we will discuss more about this mixed mode of shear failure at a later class. Okay, so any question, if you have any question, otherwise we will finish the class. Do you have any question?
No, sir.
No question?
Sir?
Yes.
স্যার বলছি c ইকুয়াল টু 0 হলে CNC টার্মটা 0 হচ্ছে, তো c ইকুয়াল টু এটা তো নন কোএফিশিয়েন্ট, স্যার এখানটা একটু বলবেন?
C is equal to 0, if C is equal to 0, then cohesion is equal to 0. That means if a soil is a purely kind of sandy soil where only soil possesses angle of internal friction, it doesn't have any cohesion, in that case your C will be equal to 0. Now when the C becomes 0, see, necessarily C0 doesn't means phi is equal to 0, right? So if C is 0, phi is 0, then there is no shear strength of soil. So when the C is 0, there may be phi, and when there is a phi, as I have said, when there is a phi in the soil, the bearing capacity factors will be having some value. The NC, NQ, N gamma, these three factors, whatever is being given by Terzaghi, they are not dependent on cohesion. They are only dependent on angle of internal friction of soil. And that is why, although the soil may be having the cohesion equal to 0, however, because of the angle of internal friction, there will be some value of NC. However, in the bearing capacity equation, if you notice, once the C is 0, you see C multiplied by NC term automatically will become equal to 0. So there is no impact of cohesion, or there is no impact of bearing capacity factor NC into the equation for calculation of bearing capacity. Is it clear?
Yes, sir.
Okay. Okay, so I think let us complete here. Let us today stop, and in the next class we will be again in detail, more detail discussing about other things. Okay, eccentricity effect we haven't told. Oh, I was thinking that we will be able to discuss eccentricity effect. Okay, we will be going little slower, no problem, but gradually we will understand. Okay, okay, thank you.
Okay, sir.
Thank you very much.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.